Hello, we're Team 2. My name is Olson.
AJ Clarey.
Alli, Hummel.
Jacob Cleaver.
Our project assignment this semester was to create a mixed design utilizing two waste products to be a suitable base material in pavement construction. The goal of this project was to determine the optimum waste oil percentage that acts as an adhesive agent and rejuvenates the reclaimed asphalt pavement. The task parameters were that our team could only use the two materials, engine oil and RAP, under cold compaction to create our test specimens. Tests were first performed with virgin engine oil, and after the optimum percentage was determined, we applied it with the waste engine oil, ran the same test, and assessed the results. Additionally, this project yields an innovative pavement base that is environmentally and economically friendly. Being that these materials are disposed of in a landfill post-consumer consumption, this project benefits the environment by extending the useful life of both materials and eliminates the costs assumed with virgin material procurement. Our team first prepared our material by splitting the RAP. This improved the consistency and provided a more uniform mix of the RAP particles. Next, we weighed portions for the respective tests, combining it with the varying oil percentages by mass. We then mixed the oil and RAP to ensure sufficient blending and better the adhesion of the materials. Once blended, we prepared the mixture into a mold and placed it in the gyratory compactor. The compactor then compressed the sample to the specified test height and yielded a solid cylindrical specimen.
After making samples, 4 samples were used to run the Hamburg wheel tracking device tests, also known as the HWDT. The purpose is to simulate traffic loads on the samples created. The samples are placed in the molds and slid into the device, while the steel wheels will travel back and forth, applying a constant load to the samples. The test is complete when 20,000 wheel passes have occurred, or a total rut depth has reached 20 millimeters. The goal is to have the samples last 20,000 passes while having minimal rut depth. The results of the HWDT test showed that the 1% oil content samples performed the best. Both of those samples lasted the entire 20,000 wheel passes, while the 1.5% and 2% reached a max rut depth of 20 millimeters. The 1% synthetic oil samples showed a rut depth of 8.35 and 8.97 millimeters. The 1% used oil samples showed a rut depth of 9.06 and 10.12 millimeters. Comparing the used and virgin 1% samples, the results are fairly similar.
Next, we perform the ideal cracking test, which is an indirect tensile test that determines the cracking tolerance CT index of the asphalt sample, which is the sample's resistance to cracking. CT index values range from 1 to 1,000, with higher values indicating better cracking resistance. To perform this test, the sample is placed in this picture as shown in the before picture. Weight is then added. The loading ends when a crack starts to form, as shown in the after picture. During this test, the load versus displacement data is collected and used to calculate the CT index of the sample. After running through various calculations, it was determined that the 1% used engine oil had the highest CT index of 62, which outperformed the other synthetic oil percentages. Our conclusion is that since the used oil is more viscous than the synthetic oil, it provides more adhesion, which ultimately increases the cracking resistance.
Through the results obtained in virgin oil sample testing, 1% oil content was determined to be optimal. This conclusion was drawn based on the combination of the HWDT and IDT results outlined earlier. 1% used oil results are also described earlier. This research shows that a mix of 1% biomass used engine oil and 1% RAP can result in an effective asphalt mix. An asphalt mix of this nature will be inherently cheap and environmentally friendly. 2 waste materials are used, so they aren't hard to acquire, and they are given a purpose they otherwise wouldn't have. Future research topics could include the climatic and environmental effects, utilizing an optimal moisture content, precipitation and extreme temperature effects, and longevity. Overall, we are encouraged by the results of this research, and we hope that it can be furthered to the point where 100% RAP and used engine oil mixtures can become an applied reality.
Thank you.